Now we've looked at any old angle theta, and then we got some number out of this, and it sometimes it was. I even said that this number is you need infinite number of digits to give the exact value. For some specific choices of the angle, namely pi fourth, that corresponds to what we in daily life call 45 degrees, pi sixth, which is 30 degrees, or pi third, which is 60 degrees. For these specific values, you can write the value of sine, cosine, and tangent very exactly in mathematical terms. So how do we do that, and how is it derived? Well, I've drawn these two triangles, the huge one here, the smaller one here. What is special about this triangle? Well, the special thing about this triangle is that obviously the length of this is 2, the length of this is 2, and the angle here is the double of this angle you see up here, so the complete angle up here will be the same as this one, and the sum of angles in a triangle is always pi, right? So all of these three angles has to be pi, so the length over here is also necessarily 2, right? So all of these lengths are 2, okay? When this angle is pi third and this angle is pi sixth. So what do we know about this? Well, we know that if we just take this angle here and this angle and that angle, then we have a right angled triangle here. We know that the Pythagorean theorem holds, right? So this is 1 squared plus something squared equals 2 squared. For this to hold, what is 2 squared? It's 4. 1 squared is 1. So 1 plus something has to be 4. That something must be 3, right? So the length of this squared must be 3. So the length itself must be square root 3. So the height here is 3. Now we know all side lengths of this triangle. We also know how to calculate the sine of such a triangle. So we are now in this case, right? We should just scale everything so that this hits this instead, right? So we divide everything by 2, and then we get square root 3 over 2 as sine of this angle. We could also have taken this triangle and flipped and then calculated the same for this triangle here with this angle. We could also have calculated that. How do we again make this 1? Well, we divide by 2, and then how do we find cosine? Well, we should say that it's now if we flipped this around so that it has this down here, we should calculate cosine by taking the square root 3 here and divide it by 2, so we get this number here. Then we can use the fundamental identity of trigonometry to calculate the last two. So this squared plus something squared should be 1. So what should that something squared be? Well, it should be a quarter, right? And what is the square root of a quarter? It's a half. And in the same way we could calculate this. And then to calculate tangent, we just say, well, this is just sine divided by cosine, and the same over here, sine divided by cosine, and we get this number here. What about the pi fourth? Again, we make a triangle. We now make this triangle. We have the pi fourth here, and a right angle here. What should we scale this with to move this point up here? Well, we should scale it such that this becomes a 1. At the moment, it's 1 squared plus 1 squared. That should be this squared. So this must be square root 2. So if we divide everything by square root 2, we get this scaled so that it hits here. And moving this around so that the angle is, we could rotate it so that the angle started as something here, right? We would see that the x-coordinate would be square root 2 over 2 for cosine, and the y coordinate would also be square root 2 over 2. This derivation is not something I expect you to remember, but you should remember that for these three values of the angles, there are exact values, and you should be able to look these up. I don't expect you to learn these by heart either, but you should know where to find them, okay?